Betelgeuse, a red supergiant located in the Orion constellation, is one of the most captivating and closely observed stars in the night sky. Approximately 640 light-years from Earth, this stellar behemoth has fascinated astronomers and skywatchers alike due to its immense size, fluctuating brightness, and the dramatic possibility of its imminent explosion as a supernova. With an estimated diameter nearly 1,000 times greater than our Sun, Betelgeuse provides an extraordinary glimpse into the life cycles of massive stars, illuminating critical stages of stellar evolution. Scientists have observed Betelgeuse's pulsating brightness for decades, noting significant variations that have periodically sparked debates about whether these fluctuations signal its final days. Red supergiants like Betelgeuse are inherently unstable, prone to massive convulsions as they burn through their nuclear fuel at accelerated rates. The star's core has likely fused heavier elements sequentially: carbon, neon, oxygen, and silicon, leading ultimately to iron, the final element produced in stellar nucleosynthesis before a catastrophic collapse. Once Betelgeuse's core accumulates iron, fusion ceases abruptly, and the star faces a rapid and dramatic gravitational collapse, culminating in one of the most spectacular phenomena in the universe: a core collapse supernova. The explosion of Betelgeuse would be an event of astronomical significance, visible even from Earth in broad daylight for several weeks or possibly months. At the moment of explosion, Betelgeuse would briefly outshine the entire galaxy from our perspective, emitting a powerful burst of light and radiation across the electromagnetic spectrum, from gamma rays to visible light, infrared, and radio waves. This immense release of energy would produce a brilliant point of light comparable to, or even brighter than, a full moon, significantly altering the night sky and capturing global attention. While such a supernova explosion would undeniably be a remarkable spectacle, the distance between Earth and Betelgeuse ensures that our planet would remain unharmed. Current astrophysical models indicate that for a supernova to pose a direct risk to Earth's biosphere, it would need to occur within approximately 50 light-years, far closer than Betelgeuse's position. Consequently, humanity would be safe from harmful levels of radiation, despite the brightness and intensity of the supernova's visible output. The scientific opportunities offered by a Betelgeuse supernova would be unparalleled. Astronomers and astrophysicists would eagerly observe this cosmic event, gathering crucial data on the processes of nucleosynthesis, neutrino emissions, and the dynamics of stellar collapse. Sophisticated detectors around the globe, such as gravitational wave observatories like LIGO and Virgo, and neutrino observatories like Super Kamiokande and IceCube, would detect the signatures of this stellar cataclysm. These measurements would profoundly enhance our understanding of the physics governing massive star deaths, neutrino physics, and the behavior of matter under extreme conditions. The aftermath of the supernova would also produce lasting cosmic landmarks. Betelgeuse's outer layers, propelled outward at velocities reaching thousands of kilometers per second, would form a rapidly expanding nebula composed of heavy elements forged in the star's final moments. This stellar debris would eventually seed the interstellar medium, contributing significantly to cosmic chemical evolution and potentially fueling the birth of future stars and planetary systems in the Orion region. The core remnant of Betelgeuse, likely a neutron star or possibly a stellar mass black hole, would remain as a testament to the star's past, a compact object offering further opportunities for astronomical observation and study. Beyond its scientific significance, the supernova of Betelgeuse would represent a profound cultural and philosophical moment, reminiscent of historical supernovae documented by ancient astronomers in China, Arabia, and Europe. Humanity would collectively witness firsthand the transient nature of stars and the cosmic cycles of creation and destruction, prompting deep reflection on our place within the universe and the fragility of stellar life. As of today, astronomers continue to monitor Betelgeuse closely, waiting patiently for its eventual fate. While predictions suggest that the star could explode at any time between tomorrow and 100,000 years from now, the uncertainty itself adds intrigue to this cosmic drama. Whenever Betelgeuse ultimately goes supernova, it will not only illuminate the heavens, it will profoundly expand our knowledge of the cosmos and redefine humanity's celestial perspective. When Betelgeuse eventually reaches its explosive finale, its bright illumination will temporarily transform Earth's night sky, dramatically altering familiar constellations. Orion, one of the most recognizable star patterns known to humanity for thousands of years, would be significantly changed, losing its distinctive symmetry as Betelgeuse fades from view, leaving behind an empty space where one of its brightest points once shone brilliantly. Astronomers speculate that the constellation Orion would, for future generations, become a poignant reminder of cosmic impermanence, inspiring new myths, stories, and interpretations across human cultures. Betelgeuse's detonation would also provide astronomers with a rare real-time laboratory for testing fundamental theories of cosmology and stellar evolution. Observations of neutrino flux during the explosion would offer crucial insights into the elusive behavior of neutrinos themselves. Elementary particles notoriously difficult to detect due to their weak interaction with ordinary matter. Precise measurements of neutrinos emitted in the first few seconds of core collapse would help astrophysicists refine theoretical models of stellar interiors, contributing invaluable knowledge about particle physics, quantum mechanics, and extreme gravitational environments. Simultaneously, gravitational wave observatories would play an essential role in capturing the subtle space-time vibrations emitted during the collapse. Gravitational wave signatures from such a nearby supernova event would revolutionize our understanding of the dynamics involved in massive stellar explosions, potentially uncovering entirely new physics and improving calibration of existing theoretical frameworks. These combined multi-messenger astronomical observations would not only validate our current theoretical understanding, but might also hint at undiscovered phenomena lurking within the cores of massive stars. Additionally, the explosive death of Betelgeuse could stimulate considerable advancements in astronomical technology and methodologies. The unprecedented observational opportunities presented by the event would encourage rapid innovation in telescope design, detector sensitivity, and computational astrophysics. Teams worldwide would mobilize to ensure continuous monitoring across various wavelengths and detection channels, triggering a global collaboration across scientific disciplines and institutions. From a cosmochemical perspective, the supernova's immense production of heavy elements, including precious metals like gold, platinum, and uranium, would underscore the profound connection between stellar life cycles and the elemental composition of planets like Earth. Understanding exactly how these elements disperse into interstellar space would allow scientists to better comprehend the origins of planetary systems, including our own, and trace the cosmic heritage of the chemical elements fundamental to life itself. Moreover, Betelgeuse's supernova would undoubtedly ignite widespread public interest in astronomy and science education. The event's visibility and accessibility would captivate global audiences, sparking curiosity and enthusiasm in millions of people worldwide. Schools, universities, planetariums, and media outlets would seize the opportunity to educate the public about stellar astrophysics, cosmology, and humanity's place within the cosmos, creating an enduring legacy of scientific literacy inspired by a single cosmic event. The long-term impact of Betelgeuse's explosion on Earth's immediate galactic neighborhood would likely be subtle yet significant. While the supernova's radiation would pose no direct risk, the expanding shock wave and stellar ejecta might interact with nearby interstellar clouds, triggering future episodes of star formation. Such processes are fundamental to cosmic ecology, marking the continuous cycle of destruction and rebirth characteristic of our galaxy's dynamic environment. Ultimately, Betelgeuse's supernova would stand as one of the most spectacular astronomical phenomena humanity has ever observed. Its occurrence would offer profound insights into fundamental astrophysical questions and serve as a vivid demonstration of cosmic forces that shape our universe. While humanity waits patiently for this stellar giant's inevitable demise, Betelgeuse continues to fascinate observers, reminding us vividly of the powerful and transient beauty inherent in the cosmos. Even in anticipation of Betelgeuse's dramatic explosion, astronomers are utilizing advanced observational techniques to gather crucial baseline data about the star's current state. Powerful telescopes like the Hubble Space Telescope, the Very Large Telescope, VLT, and interferometric arrays such as the Atacama Large Millimeter/Submillimeter Array, ALMA, have enabled detailed studies of Betelgeuse's turbulent surface and extended atmosphere, revealing enormous star spots, gigantic convective cells, and vast, pulsating plumes of stellar material escaping into space. These detailed observations have helped to refine predictive models of red supergiant behavior, enabling more precise estimations of when Betelgeuse might finally meet its spectacular end. Recent episodes of unusual dimming observed in Betelgeuse, notably the significant fading during 2019 to 2020 known as the Great Dimming, raised widespread speculation about the star's imminent explosion. Astronomers subsequently discovered that this particular dimming was likely caused by a massive ejection of stellar material, dust clouds temporarily obscuring its brightness, rather than signaling an immediate core collapse event. However, this unprecedented event provided an exceptional opportunity to closely monitor and analyze stellar processes in red supergiants, contributing invaluable data that informs our understanding of massive star evolution and their final stages. Studying Betelgeuse's approaching demise also sheds new light on critical astrophysical processes that underpin broader cosmic phenomena. Specifically, the mechanisms governing mass loss in red supergiants are key to understanding galaxy evolution and enrichment. As Betelgeuse expels enormous quantities of material into the interstellar medium, it contributes significantly to the chemical complexity and dynamism of our galaxy. This continual enrichment and recycling of materials support the formation of new stars and planets, reinforcing the intricate connection between stellar death and cosmic rebirth. Furthermore, the anticipated neutrino signal from Betelgeuse's core collapse represents a unique scientific opportunity to confirm theoretical predictions of supernova neutrino emissions. The neutrino burst, detectable minutes or hours before the visible light reaches Earth, would act as an early alert system, enabling astronomers to prepare for real-time observations across all wavelengths. Such early detection would provide an unprecedented scenario for coordinated global astronomical campaigns, uniting scientists worldwide in a collaborative race to capture the first moments of a star's explosive death. The supernova remnant of Betelgeuse, a complex nebula illuminated by the energetic shock wave and enriched with heavy elements, would serve as a powerful cosmic laboratory for centuries. Observing its expansion and evolution would offer astronomers invaluable data on shock physics, interstellar medium interactions, and particle acceleration. Potentially, if Betelgeuse's core collapse creates a pulsar or a neutron star, precise measurements of its rotation and magnetic fields would deepen our understanding of compact stellar remnants, aiding in refining theories about neutron stars, magnetars, or stellar mass black holes. The event would also carry important cosmological implications. Accurate observations of Betelgeuse's explosion would offer an exceptional calibration point for cosmological distance scales, allowing astronomers to refine measurements of the expansion rate of the universe, the Hubble constant. By precisely determining Betelgeuse's luminosity and comparing it with theoretical models, scientists could improve distance measurement techniques crucial to cosmological research. Additionally, witnessing Betelgeuse's spectacular transformation would dramatically highlight the transient nature of astronomical objects. Just as earlier supernovae, such as SN 1054, which created the Crab Nebula, and SN 1987A, marked milestones in humanity's astronomical knowledge, the Betelgeuse supernova would similarly become a historical astronomical event recorded meticulously by modern astronomers, ensuring its legacy endures through scientific archives and collective cultural memory. Thus, the eventual explosion of Betelgeuse symbolizes a monumental milestone that reaches beyond astronomy into broader aspects of science, culture, and philosophy. Awaiting the star's final act connects modern observers with an ancient tradition of skywatching, reminding us how deeply intertwined human civilization remains with the cosmic drama unfolding above. In the broader astrophysical community, Betelgeuse's eventual supernova represents an essential test of theoretical predictions about massive star evolution. Computer simulations of stellar interiors have predicted the sequence of events that unfold in the dying moments of stars, several times more massive than the Sun. However, no star is close, as bright, and as thoroughly studied as Betelgeuse has ever exploded within the era of modern observational astronomy. Thus, when Betelgeuse finally detonates, astronomers will be able to directly compare detailed observational data with theoretical predictions, potentially revising or refining models about the behavior of massive stars, neutrino emission patterns, nucleosynthesis yields, and explosive shockwave dynamics. Moreover, Betelgeuse's proximity and detailed prior observations offer a unique opportunity to study stellar environments right before their cataclysmic end. Measurements of the star's rotation, magnetic fields, surface temperature fluctuations, and extensive dust production can inform astronomers how these factors influence the subsequent supernova characteristics. Understanding such relationships might help astrophysicists solve long-standing mysteries, such as the specific mechanisms that trigger supernova explosions or why some massive stars collapse directly into black holes without bright visible explosions. The supernova event could further enhance astronomers' understanding of the impacts of stellar explosions on planetary habitability throughout the cosmos. While Earth would remain safe at Betelgeuse's considerable distance, astronomers could leverage observational data from Betelgeuse's supernova to predict radiation exposure scenarios for planets orbiting stars closer to similar explosive events. Such information could refine searches for exoplanets capable of sustaining life, potentially narrowing down cosmic zones where life could safely emerge and evolve over billions of years without catastrophic disruptions. Another fascinating scientific dimension involves studying Betelgeuse's potential remnant object. Depending on subtle variations in the star's internal conditions during core collapse, the outcome could be either a neutron star, an extremely dense stellar remnant about the size of a city, or possibly a black hole. Each possibility has distinct observational signatures, from pulsations detectable as periodic radio waves emitted by pulsars to gravitational signatures characteristic of newly formed black holes. Analyzing the precise aftermath would therefore enhance our understanding of the complex physics governing compact objects and extreme states of matter. A Betelgeuse supernova event would also catalyze advancements in public engagement and astronomical communication. Given the global visibility and dramatic nature of such an event, scientific organizations, educators, and astronomers would likely leverage the spectacle to promote astronomical literacy, boost public awareness of science, and inspire future generations of scientists, engineers, and innovators. Educational resources, public lectures, interactive digital platforms, and extensive media coverage could combine to create a lasting educational legacy sparked by the star's cosmic finale. Historically, humanity has witnessed only a handful of supernovae bright enough to be seen clearly with the naked eye. Each event profoundly impacted culture, art, mythology, and scientific thought. A Betelgeuse supernova would join this illustrious history, enriching our cultural heritage by shaping artistic expressions, philosophical discourse, literature, and even public policy discussions regarding planetary protection and space exploration priorities. Finally, in terms of cosmic perspective, observing the explosive demise of a star as well known as Betelgeuse would offer a humbling yet enlightening reminder of the scale, age, and dynamism of the universe. Human observers would confront firsthand the reality of cosmic cycles, recognizing that stellar life, like all forms of existence, is ephemeral and part of a broader universal rhythm, cycles of birth, evolution, and eventual transformation. Until Betelgeuse ultimately fulfills its destiny, astronomers and enthusiasts around the world continue to watch patiently. The uncertainty surrounding the exact timing only enhances the sense of anticipation and wonder, reminding humanity of its intimate connection to cosmic processes unfolding far beyond our world, yet ultimately shaping the very universe in which we exist. In anticipation of Betelgeuse's dramatic transformation, researchers have expanded their observational strategies, employing multi-wavelength astronomy, from ultraviolet and optical to infrared and radio frequencies to obtain a comprehensive portrait of the star's evolving conditions. Space-based observatories, including NASA's James Webb Space Telescope, JWST, ESA's Gaia, and future missions designed explicitly to study transient astrophysical phenomena, would closely monitor Betelgeuse, capturing unprecedented data during each stage of its final years. These multidimensional observations would significantly advance astrophysical methodologies, allowing scientists to piece together intricate details of stellar dynamics and supernova mechanics with remarkable precision. Astrophysicists also consider Betelgeuse's eventual explosion as a prime opportunity to study interstellar dust dynamics. The star currently sheds enormous amounts of material, creating extensive dust clouds and shells around itself. During the supernova, the interaction between the powerful blast wave and these previously ejected layers will illuminate processes of dust destruction, formation, and redistribution. Understanding this dust life cycle is vital, as dust grains play crucial roles in galaxy evolution, aiding the cooling of gas clouds, triggering star formation, and forming the building blocks for planetary systems. Betelgeuse's explosion would further provide a unique testbed for advanced astrophysical theories, such as magnetohydrodynamics, the study of how magnetic fields interact with electrically conducting fluids like plasma. Magnetic fields profoundly affect stellar winds, supernova explosions, and the shaping of stellar remnants. By observing Betelgeuse's magnetic field evolution before and after its explosion, scientists could better quantify magnetic influences on stellar mass loss, explosion asymmetry, and neutron star magnetic field formation. A successful observation of a nearby supernova event like Betelgeuse would also strengthen the emerging field of time-domain astronomy, which focuses on rapidly changing celestial phenomena. Such observations would push the development of real-time data processing pipelines, coordinated global telescope networks, and international scientific collaborations dedicated to rapid response astronomy. The infrastructure established during Betelgeuse's supernova observation would benefit subsequent observations of transient phenomena, such as gamma-ray bursts, neutron star mergers, and other explosive cosmic events. From a philosophical and existential viewpoint, observing Betelgeuse's stellar death would prompt profound reflections on humanity's place in the cosmos. A celestial event of this magnitude underscores both the immense scales and energies of the universe and humanity's exceptional privilege to comprehend and witness these cosmic processes. Public awareness of such events can enhance collective planetary consciousness, prompting deeper appreciation of our fragile and precious environment, isolated yet connected within the vastness of space. Culturally, the spectacular appearance of Betelgeuse as a bright supernova in Earth's sky could leave lasting imprints on global arts, literature, and media. Writers, artists, filmmakers, and poets would undoubtedly use the event as inspiration, exploring themes of cosmic cycles, transience, mortality, rebirth, and interconnectedness. Historically, astronomical phenomena have deeply influenced human culture, and Betelgeuse's explosion would similarly ignite a wave of creative output, enriching human imagination and collective heritage. Moreover, Betelgeuse's supernova would likely influence public perceptions of astronomy and space sciences, potentially motivating increased support for scientific research, education, and investment in astronomy infrastructure. Witnessing such a spectacular event might inspire governments, institutions, and individuals to allocate greater resources towards space exploration, astronomical observatories, and fundamental research, fostering long-term benefits for humanity's knowledge and technological advancement. Environmentally, the event would illustrate the profound interconnection of cosmic and planetary environments. As humanity contemplates the star's explosive death, scientific discussions would likely emphasize how astronomical processes profoundly influence planetary conditions, underscoring the interconnectedness of astrophysical events and Earth's long-term environmental stability. This could inspire public understanding and appreciation for sustainable stewardship of our planetary home. Ultimately, Betelgeuse's supernova represents a unique confluence of scientific, cultural, technological, and philosophical opportunities. The global anticipation surrounding this future event symbolizes humanity's profound curiosity and intrinsic desire to understand the universe. As astronomers continue to monitor Betelgeuse closely, the stellar giant's eventual demise, whether decades, centuries, or millennia away, will undoubtedly constitute one of humanity's most celebrated, studied, and cherished cosmic spectacles, permanently enriching our understanding of the universe and our place within it. In the decades leading up to Betelgeuse's final explosion, continuous technological advancements in observational astronomy will likely allow unprecedented insights into the subtle, progressive stages of stellar collapse. Researchers anticipate that refined interferometric techniques, combining the light-gathering power of multiple telescopes, will provide increasingly detailed images of Betelgeuse's surface, potentially revealing early warning signs of its impending doom. These could include pronounced pulsations, dramatic shifts in brightness, enhanced stellar winds, or unexpected outbursts of material, all indicative of rapidly changing core conditions. Moreover, sophisticated computational models will accompany observational data, giving astrophysicists tools to perform predictive simulations of Betelgeuse's collapse scenarios. Detailed numerical studies of the core collapse supernova process might predict specific neutrino emission patterns and gravitational wave signatures, allowing scientists to anticipate observational signatures and refine detection strategies. Such preparations would maximize the scientific value of the eventual supernova event, ensuring rapid, coordinated, and comprehensive multi-messenger observation. In parallel, the stellar death of Betelgeuse would profoundly influence the field of astrochemistry. Supernova explosions serve as cosmic forges, synthesizing heavier elements essential to planetary formation and potentially life itself. Detailed spectral analyses of Betelgeuse's explosion would allow astronomers to precisely measure yields of various chemical elements, tracing how these newly formed materials disperse throughout interstellar space. Such measurements can refine models of galactic chemical evolution, informing our understanding of the processes that ultimately gave rise to Earth's chemical makeup and the conditions necessary for life. The expanding debris cloud from Betelgeuse's supernova would gradually merge with the surrounding interstellar medium over thousands of years, forming complex structures visible to future generations of astronomers. Over centuries, this evolving nebula would continue to be a vital laboratory for studying shock physics, magnetic field amplification, particle acceleration, and cosmic ray production. Observing the long-term evolution of Betelgeuse's remnant would enable astronomers to study how stellar explosions shape galactic ecosystems over extended timescales. From an educational standpoint, the spectacular visibility of Betelgeuse's supernova event could lead to the largest ever coordinated international astronomical outreach effort, enhancing global science education and literacy. Schools and educational institutions worldwide could seize upon this cosmic event to inspire young students, providing hands-on activities, real-time observational projects, interactive online simulations, and virtual reality experiences to illustrate key astronomical concepts. This educational legacy could endure well beyond the event itself, motivating future generations of scientists, engineers, and thinkers to pursue careers in science and technology. Furthermore, Betelgeuse's final act might inspire philosophical and ethical reflections about humanity's long-term future in the universe. Observing the birth and death of stars reminds humanity of the transient nature of all cosmic structures, including planets and civilizations. Such reflections could stimulate valuable discourse regarding the ethical imperatives of space exploration, environmental stewardship, and intergenerational responsibility, reminding us of our fragile yet integral role within a vast cosmic narrative. Betelgeuse's ultimate explosion would symbolize an extraordinary synthesis of observation, theory, and human imagination, a convergence of scientific knowledge, technological innovation, cultural inspiration, and existential contemplation. Each facet of this supernova event, from the first neutrino detection to centuries-long observations of its expanding remnant, would leave an indelible mark on astronomy, science communication, and human thought. As humanity awaits this celestial event, Betelgeuse remains one of the sky's most closely monitored stars, reminding observers of the dynamism, uncertainty, and immense beauty of cosmic phenomena. The eventual supernova of Betelgeuse will indeed be a dramatic climax to a stellar saga, leaving a luminous legacy that transcends astronomy, reshaping humanity's understanding of itself, the universe, and the fundamental cosmic cycles that sustain existence. The scientific legacy of Betelgeuse's explosion would likely span many generations, shaping astronomy and astrophysics research long into the future. Observations collected during the supernova and its aftermath would be archived, analyzed, and revisited repeatedly as new technologies and methodologies emerge. Future astronomers, armed with advanced computational power and improved theoretical frameworks, might uncover subtle details initially overlooked, revealing deeper insights into the stellar collapse, explosion asymmetry, neutrino oscillations, and gravitational wave physics involved. The expanding nebula from Betelgeuse's supernova would serve as a vivid laboratory for studying the physics of cosmic rays, high-energy particles accelerated by shock waves, and supernova remnants. Cosmic rays significantly influence the chemical and physical conditions of galaxies, affecting star formation rates, the ionization state of the interstellar medium, and potentially even climate conditions on distant worlds. Betelgeuse's supernova remnant would thus become an invaluable site for researchers to directly observe cosmic ray production mechanisms and interactions. Moreover, the astronomical community would be able to precisely trace the dispersion of elements forged in Betelgeuse's supernova using sensitive spectroscopic analyses. By mapping the chemical enrichment in the surrounding interstellar medium, astronomers could better understand the evolution of chemical abundances across the Orion region, contributing to more accurate models of star-forming clouds and planetary formation processes. This would further illuminate the intimate connection between stellar death, galactic ecology, and the birth of planetary systems capable of harboring life. Betelgeuse's eventual demise might also provide unprecedented insight into the mysterious nature of dark matter. By carefully monitoring gravitational effects on the expanding supernova ejecta, astronomers could potentially detect subtle influences attributable to dark matter concentrations within the Orion arm of our galaxy. Such observations might help constrain dark matter distribution models, advancing our understanding of this elusive yet fundamental component of the universe's structure. Additionally, Betelgeuse's supernova could inspire enhanced international cooperation and coordination among the global scientific community. Collaborative, multinational observational campaigns would likely be necessary to capture comprehensive data during this rapidly unfolding event. Such coordinated efforts could foster long-lasting partnerships, scientific diplomacy, and open data practices, creating enduring infrastructure beneficial for future astronomical research and discoveries. From an anthropological and historical perspective, Betelgeuse's explosion would mark a rare event documented meticulously by humanity's most advanced instruments and global communication networks. Historical archives would preserve comprehensive datasets, narratives, reactions, and cultural interpretations surrounding the event, providing a rich record for future historians analyzing humanity's evolving relationship with cosmic phenomena. Finally, as humans continue exploring the universe, the memory of Betelgeuse's dramatic end would serve as a powerful reminder of cosmic vulnerability and resilience. The knowledge gained through observing such stellar events might inform strategies for humanity's long-term survival, planetary defense, and interstellar exploration ambitions. The profound realization of cosmic cycles, observed in real time through Betelgeuse, would enrich humanity's collective wisdom, encouraging greater stewardship, awareness, and responsibility in our continued journey through the cosmos. In summary, the eventual supernova of Betelgeuse is not merely an astronomical event. It represents a transformational milestone in human understanding. Its spectacular finale would illuminate fundamental astrophysical processes, inspire cultural expression, stimulate technological advancement, and deepen humanity's philosophical appreciation of existence. As astronomers and observers await Betelgeuse's ultimate fate, this extraordinary cosmic phenomenon continues to embody the boundless curiosity, imagination, and ambition inherent in humanity's ongoing exploration of the universe. The profound impact of Betelgeuse's eventual explosion extends beyond contemporary scientific understanding, potentially influencing how humanity approaches future cosmic discoveries and astrophysical events. Such an extraordinary celestial phenomenon would likely invigorate public enthusiasm for space exploration and astronomy, prompting sustained interest and increased support for observational programs, space telescopes, and planetary missions. The cultural imprint left by witnessing the dramatic transformation of one of the brightest stars in the night sky would provide powerful motivation for continued investment in fundamental scientific inquiry and education. In addition to inspiring advancements in observational astronomy, the event could drive developments in fields closely allied with astrophysics, including particle physics and cosmology. The detection of neutrinos emitted by Betelgeuse's supernova would offer an invaluable testing ground for neutrino physics, potentially shedding new light on their mysterious properties, such as mass hierarchies, oscillation behaviors, and interactions with matter. Such discoveries would enhance our understanding of the universe's fundamental particles and forces, helping physicists refine or even challenge the standard model of particle physics. Similarly, gravitational wave detections from Betelgeuse's collapse would further validate Einstein's general theory of relativity, potentially uncovering subtle deviations or unexpected phenomena indicative of new physics. Precise measurements of gravitational waves produced by nearby supernova explosions like Betelgeuse could test predictions of gravitational wave emission patterns, offering clues about physics under the extreme conditions of stellar core collapse and neutron star formation. From a broader cosmological perspective, detailed analysis of Betelgeuse's supernova explosion might provide fresh insights into the mysterious phenomenon of dark energy, the enigmatic force driving the accelerated expansion of the universe. By improving distance measurement methods through precise calibration of supernova luminosity and explosion characteristics, astronomers could refine their understanding of cosmic expansion dynamics, contributing to deeper knowledge about the fundamental structure and fate of the universe. Furthermore, Betelgeuse's supernova would likely encourage enhanced technological innovation beyond traditional astronomy. Rapid observational requirements during the supernova event would push development in high-speed data transmission, artificial intelligence for automated data analysis, distributed global networks of telescopes, and advanced computational modeling capabilities. These technological advancements could yield far-reaching applications, benefiting diverse areas of science, medicine, communication, environmental monitoring, and disaster preparedness on Earth. Public engagement with Betelgeuse's supernova event could also foster global awareness of scientific principles and scientific thinking. The real-time witnessing of a star's explosive death, paired with extensive educational outreach, might lead to widespread improvement in public scientific literacy, critical thinking skills, and appreciation for empirical inquiry. Schools, museums, science centers, and media organizations would likely harness the compelling spectacle to encourage curiosity-driven learning, inspiring a new generation of informed citizens equipped to tackle complex societal challenges. From an ecological and environmental perspective, the symbolic resonance of Betelgeuse's demise could lead to renewed discussions about planetary stewardship and humanity's interconnectedness with cosmic processes. Understanding stellar life cycles and cosmic recycling of matter could enhance public appreciation for Earth's fragile ecosystem, emphasizing the delicate balance required to sustain life and the long-term importance of environmental responsibility. On a more speculative note, witnessing Betelgeuse's explosion might also encourage humanity's imagination about the possibilities of interstellar travel, cosmic colonization, or long-term survival strategies. The profound realization that stars themselves have finite lifetimes might strengthen human resolve to expand exploration beyond our solar system, stimulating ambitious research programs in space colonization, interstellar propulsion technologies, and planetary habitability. Ultimately, the explosion of Betelgeuse represents not just a scientific milestone, but a profound moment in humanity's ongoing dialogue with the universe. Its supernova would symbolize a remarkable convergence of scientific discovery, technological innovation, cultural inspiration, and philosophical reflection, highlighting the intrinsic interconnectedness of cosmic events with human experience. As astronomers continue to monitor Betelgeuse's subtle pulsations and brightness variations, humanity awaits patiently, prepared for the transformative insights, challenges, and inspirations its eventual supernova will inevitably bring. The anticipated explosion of Betelgeuse underscores the dynamic and ever-evolving nature of astronomical research, pushing humanity's observational capabilities and theoretical understanding to their limits. As the scientific community meticulously prepares for such a rare and momentous event, numerous global initiatives, such as enhanced early warning neutrino detectors, worldwide collaborative observing networks, and rapid response satellite missions, may be established, creating an advanced observational infrastructure that will benefit astronomy for decades. Indeed, Betelgeuse's supernova would mark a landmark event in the relatively young field of multi-messenger astronomy. The simultaneous use of electromagnetic radiation, neutrinos, gravitational waves, and cosmic rays to study astrophysical phenomena. Capturing these different messengers from a single, well-studied stellar object would provide an unprecedented holistic view of stellar collapse and supernova physics, deepening our understanding of matter and energy behavior under extreme conditions. From a practical standpoint, the technological innovations stimulated by preparations for Betelgeuse's supernova could spill over into other critical areas of science and engineering. Breakthroughs in sensitive detectors developed for neutrino observatories or gravitational wave interferometers, for example, could lead to improved medical imaging technologies, advanced sensors for environmental monitoring, or novel methods for deep space communication. Beyond direct observational and technological advancements, Betelgeuse's dramatic end could have an enduring impact on international collaboration in science. Observing such a prominent event would necessitate global coordination across time zones and national boundaries, potentially strengthening diplomatic relationships through scientific cooperation. This collaborative spirit, forged by shared curiosity and the drive for knowledge, could have lasting positive effects on international relations, scientific diplomacy, and cross-cultural understanding. Furthermore, detailed studies of Betelgeuse's final moments would help astronomers refine models predicting the end stages of other massive stars in our galaxy. These refined models could enable improved forecasting of supernovae in other parts of the Milky Way and nearby galaxies, enhancing our ability to anticipate future astronomical phenomena and their potential effects on interstellar environments. The historical significance of Betelgeuse's explosion would also extend into humanity's cultural narrative. The supernova event would likely become part of global collective memory, analogous to historical astronomical milestones such as Halley's Comet, the discovery of the expanding universe, or the first images of Earth from space. Future generations would look back at Betelgeuse's explosion as a defining moment in humanity's understanding of its cosmic surroundings, potentially influencing philosophy, art, literature, and even societal perceptions about our collective role in the universe. In the long term, observing Betelgeuse's supernova and its expanding nebula would guide astronomers' efforts to identify past supernovae remnants within our galaxy. By studying the chemical composition and structural features of Betelgeuse's expanding debris cloud, astronomers might better interpret the history of previous explosions in the Milky Way, reconstructing a more complete narrative of our galaxy's cosmic evolution and its chemical enrichment history. Finally, the eventual fate of Betelgeuse highlights humanity's shared relationship with the cosmos, reminding us of the finite existence of stars, planetary systems, and ultimately, all structures within the universe. By witnessing firsthand such profound cosmic transformation, humanity would gain renewed perspective on our own existence, promoting a deeper appreciation of the interconnectedness of cosmic processes, planetary ecosystems, and the human experience itself. In awaiting the supernova of Betelgeuse, humanity stands on the threshold of a remarkable scientific and philosophical revelation, one that transcends generations, bridging past knowledge with future discovery, and forever altering our comprehension of the universe and our place within it. As astronomers continue monitoring Betelgeuse, ongoing refinements in both theory and observation will further enhance our readiness to capture the star's dramatic final moments. Observational astronomy will increasingly embrace automated and AI-driven methods, ensuring telescopes worldwide are immediately alerted and synchronized at the very instant neutrinos or gravitational wave signals indicate the beginning of Betelgeuse's collapse. Such instantaneous global coordination would maximize observational coverage, providing comprehensive data sets invaluable for subsequent detailed analysis. The data acquired from Betelgeuse's supernova would undoubtedly stimulate rapid advances in computational astrophysics. Sophisticated numerical simulations, empowered by enhanced computing infrastructure, machine learning, and artificial intelligence, would interpret the immense volume of observational data. These computational tools could reveal previously unseen details in stellar evolution and supernova physics, guiding astronomers toward more accurate and predictive theoretical models. Additionally, detailed studies of Betelgeuse's remnant could advance our understanding of astrophysical jets and relativistic outflows often associated with stellar explosions. Observations of the expanding supernova ejecta would allow astronomers to directly analyze how such high-energy phenomena shape their surrounding environment, accelerating particles, influencing interstellar chemistry, and interacting with galactic magnetic fields. These insights would enhance our knowledge of similar energetic phenomena across the universe, from active galactic nuclei to gamma-ray bursts. The cosmic event would further benefit studies of astrobiology and planetary habitability. Although Betelgeuse poses no direct risk to Earth, understanding radiation output and energy deposition into planetary atmospheres during stellar explosions can refine criteria for exoplanet habitability. These insights could guide astronomers as they search distant star systems for signs of potentially habitable worlds, shaping future missions designed to discover extraterrestrial life. Betelgeuse's explosion could also enrich the ongoing discourse around planetary defense, space sustainability, and human exploration strategies. Witnessing such dramatic cosmic events can prompt thoughtful discussion on humanity's long-term preparedness against astronomical hazards, such as near supernovae, asteroid impacts, or solar events. Lessons learned from observing Betelgeuse would strengthen policies aimed at safeguarding Earth's biosphere, promoting responsible exploration, and enhancing our resilience against cosmic threats. Moreover, the global cultural impact of Betelgeuse's supernova would undoubtedly foster creative expressions across various disciplines. Visual arts, literature, cinema, music, and digital media would interpret the event, inspiring new forms of cultural engagement with astronomy and space sciences. Artistic interpretations could offer powerful emotional narratives to complement scientific explanations, deepening public understanding and appreciation of cosmic phenomena. Educational curricula worldwide would evolve to incorporate the event's scientific significance, integrating astronomy and astrophysics more profoundly into basic education. Future students could learn about Betelgeuse's explosion as a central case study illustrating key scientific principles, from nuclear fusion and stellar evolution to the cosmic origins of chemical elements, strengthening their scientific literacy, critical thinking, and curiosity about the universe. Finally, the eventual supernova of Betelgeuse would symbolize a universal milestone, uniting diverse peoples and cultures through shared observation and wonder. The event would reinforce humanity's collective identity as observers of the cosmos, highlighting our shared responsibility to understand, protect, and explore the universe. Through the extraordinary scientific, cultural, and philosophical impacts of Betelgeuse's supernova, humanity will reaffirm its enduring curiosity, adaptability, and interconnectedness within the vast cosmic landscape. In contemplating Betelgeuse's eventual supernova, humanity finds itself not merely observing a distant cosmic spectacle, but deeply connected to a fundamental truth about the universe: the perpetual cycle of creation, destruction, and rebirth that defines all cosmic evolution. This impending stellar cataclysm, whenever it occurs, will stand as a powerful testament to the interconnectedness of matter, energy, and life itself. It will reinforce the profound realization that the atoms forged in stellar furnaces and scattered into space by stellar deaths are the very building blocks of our own existence, bridging our human story to the vast expanse of cosmic history. As astronomers patiently await the final act of Betelgeuse's extraordinary stellar drama, continuous monitoring and technological advancements will ensure that when this red supergiant finally explodes, humanity will be fully prepared to capture, document, and interpret this awe-inspiring event in unprecedented detail. The data and insights gleaned from Betelgeuse's supernova will drive generations of scientific research, offering new answers and sparking new questions in stellar astrophysics, particle physics, cosmology, astrobiology, and beyond. The transformative effects of witnessing such a powerful astronomical phenomenon will inevitably extend beyond science, deeply influencing our global culture, philosophy, and collective imagination. Betelgeuse's luminous demise will inspire art, literature, philosophy, and education, enriching human perspectives on our place within the cosmos and fostering a more profound sense of planetary unity. Its spectacular brightness, observable to all people on Earth regardless of geography or culture, will symbolize our common bond as inhabitants of a tiny planet orbiting an ordinary star within a galaxy teeming with stellar birth and death. Moreover, the legacy of Betelgeuse's explosion will permanently reshape how humanity engages with the universe. It will underscore the essential value of sustained investment in scientific inquiry and international collaboration, guiding future generations toward cooperative ventures in astronomy, space exploration, and planetary stewardship. The innovative technologies and collaborative frameworks developed to capture this stellar event will continue to benefit society long after the star has faded, advancing fields ranging from communications and healthcare to environmental monitoring and global scientific diplomacy. In reflecting upon the grand cosmic narrative embodied by Betelgeuse, humanity will inevitably confront deeper philosophical insights about existence itself, recognizing the ephemeral nature of stars, planetary systems, and indeed all cosmic structures. This realization, far from diminishing our sense of purpose, will enhance our collective appreciation of life's fragility, beauty, and significance within the boundless cosmic tapestry. Observing Betelgeuse's death, humanity will gain a profound and enduring appreciation for the delicate, dynamic interplay of forces and events that sustain existence itself. Ultimately, Betelgeuse's explosive end will serve as a lasting beacon illuminating humanity's ongoing quest to understand our universe and ourselves. By preparing for and experiencing this extraordinary astronomical event, human civilization will gain invaluable knowledge, technical capabilities, and cultural perspectives that echo across centuries. And as future generations look to the stars, the remnant nebula left by Betelgeuse will remain visible, a cosmic monument to curiosity, discovery, and the enduring human endeavor to comprehend our universe, a testament to the profound connection between humanity and the cosmos, eternally guiding us toward further exploration and understanding.